All right, so for problem number 6, it says a projectile has an initial velocity of 26 meters per second. The projectile has an x component of 6.4 meters per second and a y component velocity of 25. What is the range of the projectile? Oh, okay, this is a different one. So, in order to do this, the range. All right, I see what they're saying. So first thing we do when we do a physics problem is we have to draw a picture. So we're assuming that it's on level ground because they don't tell us any different. And so I have this object like this, and it's going to travel this path like this. Okay, and it's going to land over here. All right. And then what they're telling us is that it has a velocity of 26 meters per second. That's v naught. It has an x velocity of, what was the x one? 6.4. 6.4 meters per second. And then it has a y velocity of 25 meters per second. So it's a pretty steep angle. Well, to figure out the range, remember that the range equation is that, and then so this and this is delta x. So for the range equation, delta x is actually equal to does anybody remember what the range equation is? Somebody tell me. I always write it down. I don't think you guys know how to look in your notes. Look in your notes and tell me what the range equation is. Real quick. Now, it might not start with delta x. It might just say range. I'll give you a clue. It has sine and cosine in it. So now I know what the range equation is, but let's say you're doing your homework at home. How do you find the range equation if you can't find it in your notes? We did it. We wrote it down, but how could you find it? Huh? You can watch the videos, or you can just Google it. Let me show you something, you guys. When you're let's assume you're stuck at home. How to find the range of a projectile. All right, so if I pull this up, there's the formula right there. That's the range equation. Now that's one version of it. There's another version of it. The one we did doesn't have the double angle. Okay? The one we did doesn't have the double angle, but that one would work. But there's all these you could look it up here too, right? But also, I have listed it in your notes, right? So if you couldn't find it there, then you could just go to your notes and look it up. So where is it in your notes? Well, I'll pull it up and show you. So if we go right here, if I go right here in the t-shirt launcher thing, right? Our most recent notes, because that's what our homework problems are on, are right here. So I'm going to go to this right here, which is a YouTube video that I recorded. I heard somebody said that. They said you could watch the YouTube video. And now I know where all this stuff is because I've been teaching this for years, but you could find it and you just review this real quick, but at the end, there's always a summary of the equations. So, and this is what you should have these in your notes. Of course, the internet's really slow. Hey, this is important. We'll need this. See this equation right here? Now, this is what you should have written down. If you wrote down everything that I've written down, the notes from this last section. So when I do the homework, it's going to be based on the notes from that we just did. So we did the notes. I did a bunch of example problems. And now your homework's going to have similar example problems using the same formulas that are in that section of the notes. So we're going to use this for sure. But I think what we're really looking for, there it is, right there. That same equation that if you wrote your notes, if you wrote down what I wrote down, it should be right there in your notes. Find that in your notes. Do you find it? Okay. So when you go to do your homework, I'm writing all the notes so you don't have to look stuff up in the book. These notes, while it takes us a long time to write them down and you have to listen to me explain them, it's a short version of the important stuff. You just got to look, okay? You just got to look. Now, what's funny is I said, do you guys have them in your notes? And everybody was real quiet, and I heard some people kind of flipping through your notes. But it should be the very last thing we wrote down, okay? And I don't, just look in your notes. You guys need to read your notes, too. So when you do your homework, you should literally have your notes right next to you, and you should flip through it and try to find those equations. Anyways, what was that equation again? Somebody want to tell me? Did you find it in your notes? What do I write down? V not squared sine of 2 theta all over what? Yes. G. So we know that G is gravity, the acceleration due to gravity, which is negative 9.8 meters per second. Now, this negative thing, the formula, sometimes you plug in the negative, sometimes you don't plug in the negative. Remember, in our notes, when we say G, we leave it as a positive. So sometimes you'll see this formula with a negative G. Sometimes you'll see it with a negative A. We just need to keep track of that in our head, okay? But the way that we set it up in the beginning is we said that G would, for the most part, if the formula had a G in it, it would be negative. But the reason I'm warning you and asking you to think about it is if you Google the formula, right? So this formula that I looked up, it probably has a negative for G. Where did I put that at? Was it here? That's the one that we did. Where's the one that I Googled? No? All right. Well, we'll see how this works out. Oh, wait. what's the angle theta? Remember that theta, now I know how to find all this stuff. I want you guys to think about it. Theta is this angle right here. What is that? So think of this in terms of geometry. I have a right triangle that has an angle theta, right? How do I find that? Well, I said in your notes, if we look in our notes, it's right here in the notes. So if you go back, that's how you find it, right there. It's literally right there. You guys find that in your notes? Did you write that formula down? Okay. So to find theta, and this is what makes physics hard, is you have to kind of think on your toes, but once you do it, you get the hang of it. So to find theta, theta is arctan of, and since we're using velocities, we're going to say v sub y over v sub x. And we know those numbers. So theta is arctan of 25 over 6.4. And that we could do on a fancy calculator, maybe not so fancy calculator, I don't know. Oh, I'm going to have to use a fancier calculator. So Desmos, by the way, did you guys use Desmos on the PSAT and SAT yesterday? Yeah. So I would encourage you to use Desmos on all of your math homework. That way you get familiar with where everything is. So I'm going to say arctan of what was the top number? 25 and then 6.4? I hope so. So it's about 75.6. Wait a second. Degrees? Hold on, let me think. Oh, that's theta, right? But what do I have to do? Well, let's see. I don't know if this is going to work out. So we said that theta, we'll find out in a second. Theta is equal to about 75 degrees, roughly. Okay? But I got to multiply that by 2. So that's going to be about 150, roughly. So let's plug this in and see what we get. 26 squared times sine of 150 divided by 9.8. Let's see what we get. I'm going to do that in Desmos. So it was 26 squared times sine of 150. 150. Let's see what that is. 338 divided by 9.8. I forgot which question was that. Was that 6? Yeah. Let me look. I think it was closer to 151. Let me double check on my calculator to see what that angle was. Because that changes it a little bit. If I say, we got to be very precise. because it's slightly off, right? So what did I say that angle was? 75. It was, well, now I got to do it again. So 20. It's slightly off. Mr. Adams rounded. So this is what I have to multiply by 2. Okay? So I'm going to take that, and I'm going to say, actually, I'll just do it like this. We'll do the math over. I'm going to say 26 squared times the function sine of. Then we're going to say 2 times, and then I'm going to plug this number in. I'm going to say 75.64, and we'll just round it there, okay? Because that gives me a slightly different number. So now if I divide that by 9.8, so if I say 324.84 and I divide that by 9.8, man, you got to be very precise on this. All right. So we've got some rounding here. And the reason I say that is, let's see what our options are. So I'm saying that delta x is about 33. Do you know what I mean when I say rounding here? It means that we rounded some of these numbers when we did the math, and we might not have the exact same answer. So let's look over here. So let me look at the exact problem. That was problem number 6, right? Yeah, so about 33 is the answer, right? B. Well, it might be different for you guys. Any questions on that? So I'm kind of glad that I kind of did it that way so you guys could see. Sometimes you could get, like, originally we had 34. And we had 34 because it isn't exactly 150 degrees. It was more like 152 degrees. So that changed the final answer. So you usually, and I don't know why I broke that habit, you usually shouldn't round until you get to the very end. You should leave as many decimals as possible and then round.